Just to reminisce. Hi everyone, thanks for having me. I am so excited to be speaking to you all. I was going to introduce myself, but Ben did such an awesome job of that. I'm just going to jump straight in. I do want to survey the room because it's my first time here. How many of you use TypeScript at work already? Okay. So this is good because this is meant to be a gentle intro, and hopefully those of you who already do use TypeScript have a new perspective at the end. And we're going to talk a little bit. And I work in LFI. I very much joined 3 months ago, and therefore I can't take any credit for the awesome developer experience. But I'm here to also share with you. So who here uses LFI or has heard of LFI? Show of hands. Awesome, cool. So those of you who didn't raise your hands, just talk to someone that has. We very much care about the future of the web and Nullify, and that's really something that I think is a developing story. If you use React, you're going to see more and more TypeScript adoption in React. I'm here to show you how to get started, and then I'm going to end with why you might even want to do that. So it's a little bit reversed. Typically, you start with why. But we're all social animals, so we're going to do obligatory social proof. And in the 2 recent surveys of the JavaScript ecosystem, this is NPM COO Lori Voss surveying and NPM users and saying that 46% are using TypeScript. This is the State of JavaScript survey showing 47% TypeScript and 33% desire to learn TypeScript. This is Facebook just migrating to TypeScript only in the past couple of days or so. This is Expo. If you use React Native, you will know what Expo is, also moving to TypeScript. Atlassian, this is React Beautiful D&D, but all of Atlassian, so the makers of Jira and HipChat and whatever, all moving to TypeScript. And this is Google. Every single product at Google uses TypeScript. And obviously Microsoft, who makes TypeScript. So that's the social proof aspect, and hopefully that sort of piques your interest as to like why are people adopting this so much. My goal here is don't worry about the text. My goal here is to just get you to see that it's actually not so intimidating, and I'm going to start by showing you that this is a blank folder. So I have a fresh folder here, and we're going to do npx create React app, which is called this my app. And then we'll add a TypeScript flag. So if you know create React app, you should know roughly this command, except for the new TypeScript flag. And this is support that was recently added when Babel 7 was dropped. So there was a chain of events. Babel 7 dropped, and then they incorporated it into create React app. Babel preset TypeScript was made for Babel 7, so that also got added. And now create React app has TypeScript support. So that's I just did a live coding npm install, so that was very brave. So now we're going to go into a fresh create React app instance. So I just want to make sure that you're following along because this should be familiar to everyone in the room, and I care a lot about making sure that this is approachable that way, right? So we're just going to run yarn start, and this is going to take a while because of Webpack, but if you look at the code here, I'm going to split my screen a little bit. So if you look at the code here, you'll see that this is pretty much a standard JavaScript JSX sort of code base, right? If you know React, you know the screen very well, and it's overall very true that valid JavaScript is valid TypeScript. So that's like sort of your first comfort layer. But then let's also make it interesting, right? So now let's actually start to make our first thing in TypeScript, and that's going to be a component, a function component. So I'm going to create a component folder, and then I'm going to add button.tsx. All TypeScript components have to use the TSX extension and not TS, and that's just for avoidance of confusion. That's something that they decided early on. You can import React from React, similar to like you do in JavaScript, although legacy versions of TypeScript have this older syntax where you have to import star as React from React. I'm going to use that today just for compatibility reasons, but in most situations you'll be able to do import React from React. All right, so and then we're going to create a function component. So const button equals star whatever button hello world, and export it. Hopefully all this is very familiar. I haven't written a single line of TypeScript yet, right? Like this is all JavaScript. Import button from /component button. All right. And I'm going to remove all this gruff. So right here we have this very nicely rotating thing. We thank it for its service. And we wish it all the best. And here's the button component that we just wrote. Okay, so this is kind of small. We're going to make sure that hopefully this room is kind of long. It's kind of hard to show on the screen, but hopefully you can see what I'm doing. So far, all valid JavaScript. Agree? Awesome, cool. So now let's actually start adding some code into here. So let's say I want to take a string and then make this dynamic, right? Make this text hello world dynamic. So I'm gonna destructure my props. So I'm just gonna say, for example, text label, and then I'm gonna put it in here in the text of the button. And here we start having our first error. In TypeScript, the TypeScript server, because this is a TSX file, tells us that this is implicitly an any type, and any type is inferred whenever there's nothing else to infer from. So we got to give it a hint as to what the props of the component that we're writing should be. So here we start writing our first TypeScript stuff. So type button props, and then we'll say, for example, text. We expect the prop of text to come in to be of type string. And we can supply that to our component. Okay. And will this work? Will this work? No, because we've over here in app.tsx this is updated, and our compiler knows that we now expect a property of text, and we haven't given it. So in fact, if you see over here, it says fail to compile. So it just doesn't let you write invalid code. So you should write, for example, let's just say text equals hello real world React, and that shows up over there. Okay, so nothing super exciting. I also want to show you the completeness, for completeness sake, the length of the type system. So there's all these types. You don't have to read through it, but you've got number, Boolean, undefined, void, string arrays, string literals, all this objects, arrays of objects, and all this other stuff that you can take your own time to learn. But just to show you the fullness of the type system that has been developed. But okay, so let's add another prop, right? That one prop's not good enough. We're going to add more props. And this one we're going to call it border, and we're just going to have it depend. We're just going to have it be a result of some kind of state. So again, let's call it a string, and we're going to destructure that here, same as usual. I'm going to make this a multi-line sort of component. Huh? Oh, thank you. And I'm gonna base a style prop on top based on that. So style equal whatever border, and let's say 5px solid. This is probably the worst CSS you've ever seen, but just bear with me. Success, and then if it's successful, I'm gonna say green, right? Add a green border, and if it's not successful, I'm gonna say add a red border. And lastly, I'm going to pass my style into there. Okay, so what have I done? I've added a border prop, which expects a string. The string compares to the hidden string success here, and if it does show success, then it will be a green border. Again, will this pass? No, because over here, back here, it's gonna be linting for me, and this inside the terminal, it shows you exactly where your code broke because of code that you made. Code changes that you made elsewhere in your app. So that's very, very fast iteration cycle. I don't even have to compile my app to see what I broke. So let's call this style, well, what did I call it? Border, success. And I should be able to see over here the green border of it. I can similarly type error, and it should say red. But notice what happened. I misspelled error. I spelled it ERROR here, and that was still a valid thing because what did I do over here? I wrote a ternary, right? It says just compare any string to success, and if it's not success, then just make it red. But that's an invalid state, and that will cause downhill implications if I'm not careful. So one of the things that TypeScript offers you, for example, is string literals and union types. So here, instead of saying just accept any string, I'm going to say specifically only accept two strings, success or error. So now it fails to compile because I mistyped error, right? So I literally cannot compile unless I spell error properly. And don't think about this as just like correcting typos, but think about this as like object shapes, array lengths, anything that your JavaScript lets you do a lot of stuff, and this really constrains the amount of degrees of freedom that you have to shoot yourself in the foot. And this thing is so powerful that even inside my code, so I spelled success and error over here, I can also misspell within my own code. So I've got component and app code. I can misspell within there, and it shows me exactly where it went wrong. Thank you. So that's pretty awesome, right? And now we're gonna add one last thing, which is no, you know what? I'm just gonna skip ahead to turning this into a class component. So function components are great, but you really want to have class components for state and other things. So let's do that. Let's get there. Extends, React, route component. Again, valid TypeScript, valid JavaScript. And then I need to destructure this from props. Okay, so almost there. This would be valid JavaScript, valid JSX, but something's wrong. I haven't given it the props. It doesn't know what props to take. So TypeScript has a syntax where the component constructor accepts some generic type variables. So here we're going to pass in the button props that we defined above. And similarly, you can define your state as well for your class components. So that's all well and good, right? And now we've imagine that you've built out. Okay. Well, forget it. Actually, no. I need to show the activity bar. All right. So imagine that you've built out a whole component library, you've built out your app. You also want to document your stuff alongside it. So this is where the constraints of TypeScript really help in terms of showing in terms of developer tooling. So let me just sort of bear with me. I'm gonna do some slight modifications, and I'll show you what I mean by what is attractive about opting into this kind of developer tooling. Okay, so we're going to install Yarn docs. So docs is similar to Storybook. It helps you document and play with your components outside of the context of your app, so you can reuse your components. And it's really good for working with designers. And in order to configure that, basically all you have to do is you have to create a docz rc file, .js, and docs.rc, and then I'm gonna, just for convenience, I'm also gonna add a npm script over here and give myself a docs command, but it's really just like a few characters. I'm just being lazy. Finally, okay, so I've installed docs and I've set it up. Finally, I start to write MDX alongside my components. So I'm interested in documenting my stuff. So in MDX, if you're familiar with Markdown, MDX is Markdown plus JSX. So you can mix in your text for documenting your components together with your React components. So again, I know I'm asking a lot of you to take this on faith, but just trust that, So for example, I'm scaffolding out some stuff here, but let's just run this and see what happens. So I have my app running, right? And imagine that it's a non-trivial app, but because you can't live code all that much. But just to show, oh, hopefully I've done this right. Okay. Okay, so I've documented my component, right? And I show different states of it. This is really great for designers, product managers, right? For yourself in the future. Imagine you have a whole layer hierarchy of components as well. You can live edit your components. So I got hello world here. I can say hello real world. React. It's amazing, right? And it documents all the prop types as well, and you got even more documentation for external stuff that is not code. So that's really great. But wouldn't it be nice if you had some comments alongside of your props as well? And that's something that's also very nice. If you use what is the equivalent of this? JSDoc? Yeah. If you use JSDoc, nice. So if you use JSDoc, this will be very familiar, but because of all the types that you've already written, a lot of stuff just goes away, right? So this is a variant of JSDoc called TSDoc. And here I'm just going to say, for example, this is the text of the prop, the button, whatever, right? It doesn't really matter. This is the order status of something. Doesn't matter. And you can see as I save them, it kind of shows up here. So fully documented thing for your component, for your props, everything, so that everyone that's working can have the same reference as they work on your main app, right? So that's just a little glance at like the degree of developer tooling that exists in the TypeScript world. So hopefully I've kind of sold you on that. I'm going to wrap up my talk with some calls to action, pointers to more stuff if you're interested. And I'm going to do that by adding it in directly to the documentation that we set up, because why not? So I definitely recommend advanced types. So this is so what I've shown you today is just basic typing, and there's all these advanced types where you can sort of grab. Don't worry, I'll tweet this out later. Basic advanced types where you can grab, modify, reshuffle, whatever. It's just really fun. But then also sometimes too fun, and I'll get into that as well. And there's definitely typed, which is the community typing. So let's say the library that you're using, for example, React, it doesn't use TypeScript. The community people who use it will be maintaining that on the definitely typed repo. And also here be dragons. I'm not here to sell you something that is perfect, right? Like there are holes, there are legitimate criticisms, but there's some that are not so legitimate. So hopefully we've sort of dealt with some of them today. TypeScript isn't perfect. So these are the three that I would suggest. First is generic type logic. It can be really sort of Greek. I'm gonna load this up. The internet's fast enough where I can kind of show you. This takes a while to understand, and that's sort of generic type logic. Don't worry if you're at the back. Yeah, I can't read it either. There's conflicts between TSLint and ESLint, and this actually was valid all the way until pretty much last week when the TypeScript team basically said, all right, we're discarding TSLint and we're doubling down on ESLint. So they're very, very much involved with the community and interested in success. And third is most core to my heart, bikeshedding. If you already bikeshed on like the tabs versus spaces or like the way you format your code, this gives you more ways to format to bikeshed about your types. And that can be hard, but really it just solves different problems for you, and you have to agree as a team what your components need to do, what your types are contracts for between yourself and your apps. And really I want you to focus on why you want to use TypeScript. And it's the same reason as why you want to test your code, which is you want to achieve correctness. All of us as programmers, we have this thing in our heads, right? This is everything possible with our code, everything possible in the space of possibilities. But then we don't want all of that. We just want this little green circle. That's what's in our head. This is how we want our code to behave. How do we ensure that happens? We can write tests. We can write tests that go red when it's outside of the stuff that we don't want to do. We can write tests that go green when they're testing the stuff that we do want to do, right? But it's very laborious to just keep writing all these points, ... And you don't even know if you really covered it. The opposite approach, which no one really talks about, type-driven development, is write your types first. Like, what should my props accept, right? And have this sort of vague green circle that kind of overlaps the green circle that you really want. And then narrow that down, just like we narrowed down the string into string literals. Narrow that down as much as possible into the possibility space. So these tests and types go together, but one is very much more powerful and takes a lot less effort, like I showed you today with the live coding. So we're almost done. And blah, blah, blah. If you want more of that perspective, check out Gary Bernhardt's ideology. That's the guy that gave the WAT talk in JavaScript. There's two more ways to look at TypeScript. One is shorter feedback loop, so you will get more errors. We ran into so many errors as we were coding, right? But we get them faster, right? And it's preferable to having less errors that are further away from when you coded the thing that you were coding on that was causing the error. So you want to decrease distance to your code, and you don't really care that much that you have more errors because you'd rather have them now. The last way I like to pitch it is that it's basically a free team member for pair programming. It's this annoying thing on your shoulder that's just saying, all right, oh, you misspelled this, oh, you forgot this prop. Like, it's always doing that, always, right? So how much would you pay for that? So that's it for my talk. Some calls to action. I'm maintaining a cheat sheet that the community sort of rallies around as documentation for React and TypeScript because the React docs don't do it. There's a basic level for sort of introducing everything that we walked through today, and an advanced level for advanced sort of type logic and stuff. We also talk about TypeScript on r/React.js. There's 88,000 of us, and we do love TypeScript a lot. And I'm going to be tweeting out this talk and all the resources on my Twitter, twitter.com/Swix. Thank you very much.